Hey guys, welcome back to another video. So in this video we will be discussing about how to use all the different kinds of PBR maps which we get in PBR material, and I will also show you how to use displacement map. So let's dive into the video. So first of all, I will delete all the default objects and add a plane. So let me turn on the screencast. Now I will scale it 4 times, convert the render engine to cycles, and add a sun lamp. Let's see how it looks. Alright, now I will split this section and convert it into shader editor. Then I will again split it and convert it into the file browser so you can see what's going on. So for this video I have downloaded this brick texture. It is a PBR of 4K resolution. Normally you get 5 maps. The first one is diffuse map, which is also called base color map. The second one is displacement map, which is also known as height map. The third one is the normal map, which is kind of important one. Then the fourth one is the roughness map, and the fifth one is ambient occlusion, which we will be discussing at last. Now I will add a principal shader. Here you can see. So first map we will be using is diffuse map, or you can say base color map. I just simply grabbed it here. All you can do is add an image texture and open this same image. So I plugged it into the base color. Here you can see we have got this image on our plane, but it is still a plain image. There is no lighting data, or there is no shadows cast by the bricks or anything else. It is just a plain plane. Okay, so now this map is an important map. We will add this normal map here. Then to use this we will add a normal map node. Now if you see this, there is no data according to this, but if you see the image you get this data. This data provides how the light has to bounce off along these edges and along these bricks, and also how they cast the shadows. So I will plug this color into the color of normal map node, and then the normal to the normal of principal shader here. If I show you the output, this is what we get. This is without normal and this is with normal. Now if I rotate the sun lamp, you see that the bricks cast shadows and it just does not get completely blank. You can see the part exposed to the light is shiny and the part which is not is dark. So this is what normal map can do. Okay, so if I rotate it, you see it is so much shiny. This is not what an actual brick looks like. So here we have our third map, which is roughness map. What roughness map does is it provides the data of which part is shinier and which part is rough. So if I show you the roughness map, this is what it looks like. The darker parts are shinier, the white parts are rough. Now if I connect the roughness map to the roughness node here in the principal shader, you can see the difference. The part which has cement and all is rough, and the burnt part is also rough, but some parts are shinier. I'll show you in the EV so you can better see the change. EV requires RAM because it instantly renders, so that's why it is laggy for my laptop. So I prefer to use cycles instead. Okay, so you can see how good it looks. Let me show you here. I will remove all the maps except for the base color map. This is the difference between both of them. This one has normal and this one doesn't have anything except for the color. Now if I rotate the light, you can see the difference. See how normal map reacts with the lighting. But still, if you look it from a certain angle, you will see that it is still flat. It is still just a plane without any displacement or say up and downs. It is just a flat plane. Now till here this method works for the games in which you don't have a certain perspective to watch, so it looks almost realistic. But if you want to make a scene which is close shot, you will see that it doesn't look real. Now for that we have our fourth map, which is called displacement map. To use displacement map, you have to import this image here, then simply add a displacement node, connect the color. First I will show you what displacement gives. It has nothing, no data right now. But if I connect this color into the normal, into the height, you see this data. The black parts are below and the white parts are above. Now I forgot to show you one thing. If I click on the normal map, it still doesn't show better details. It still doesn't show the better details of the map. Now to see proper details, you have to turn this from sRGB to non-color. because the normal map has color data too. So if you don't want color data to interact with the normal, you have to set it to non-color. Now you see you got more details. Similarly, you have to set it for roughness, but if you set it for the base color map, it is the only data it is providing. So if you set it to non-color, there will be no color, so let it be. You see those cracks here? This is what normal map can do. It became far more better than it first was. See how it reacts with the light. Now this is how actual normal works. Right? So we were at the displacement. Now I'll show you what displacement offers. You see this image is still not good because it is set to sRGB. I will set it to non-color. Now here we have our real data. The blue part you see is above, means embossed upwards, and the black part you see is below, downwards. Now if I plug this, EV takes too much time. Okay, so now if I plug this displacement data into the displacement here in the shader output, you see there is no difference, almost no difference. Now to make it work, I have two methods. One is for cycles only, and the second one is also for EV, which works with both of them. So first I will show you the first one, the cycles one. Okay, so you still see no displacement here. I will set. Now to make it work, what I will do is I will set this. I will go to material and go to settings, under which there is surface, in which there is displacement, which is set to bump only. Now bump works with the normal, which means bump is the data by the normal. Now if I change it to displacement and bump, you see the image has risen above. Now this is because we don't have actual geometry in our scene. We have just 4 vertices, so there cannot be any displacement. Okay. So if I increase the geometry, I'll set it to simple. You see there is the bending and the folding, which means there is an extra vertices here in between from where it has fold. If I increase the geometry, you see this is what displacement does. Let me set this value lower. I'll set scale to 0.25. So you see the part which is upwards is the part which was blue, and the part which is downwards, the part with the cement, is downwards. Now if I increase the actual geometry, there is a problem. The render time will also increase. I will subdivide this plane, or what can I do is just duplicate this one. So currently it is 65,000 faces. What I will like to use is the experiment feature which Blender offers us. If I change this from supported to experimental, you see there is one more extra option here we have in our subdivision. If I take this, what it will do is align the vertices in the place where it is needed. If we increase the subdivision, there is more detail. Simply let me subdivide it 4 times. Now here you have 1 lakh vertices almost. More the vertices, more the details of the bricks you have. Let me decrease the scale. So now you see this is the actual displacement we are having from the data of this displacement. But if you go to solid view, you still see a simple plane, and unfortunately this method is only applicable with only for the cycles. So if I convert it to EV, it is not going to work. Now to make it work with the EV, what you have to do is there is no need of this displacement map here. What you have to do is add a modifier called Displacement Modifier. Add a new texture and set it to image or movie. Then I will select the displacement here. So here you can see this is the actual displacement, similar to the first method provided by this displacement modifier. Now this is real displacement. It is also showing up in the solid view, so it works with the EV. Now what I will do is decrease the strength. So you see these are some nice bricks here we have. You can shade it smooth if you don't want to increase, or you don't want those sharp edges. Or you can do is increase the subdivision. I will decrease this and subdivide it one more time. So you see, if I increase the subdivision, the details also increases. Let me show you in the rendered view. That's how it looks. Oh, let me convert it into EV. This is what it looks like in EV. If I rotate the sun lamp, you see how good it looks, right? I'll shade it smooth. But the problem with this method is that you have to throw so many faces and so many vertices for the detail you want to achieve. Now to fix this, I have an idea. First I will apply the subdivision modifier, then also apply the displace modifier. Now I will add the decimate modifier. What this modifier does is it removes the extra vertices which are not needed. So first I will show you how it looks with the displace modifier applied and those extra vertices which are not needed. So here you can see these are so many unnecessary vertices. To remove that, what we will do is decrease this ratio. Here you can see the face counts which are almost 4 lakh. If I decrease this to 0.2, you see there is drastic change in the face count and almost negligible change in details here. There is almost no change between these two, and this happens mainly because we also have bump and normal turned on. So I will apply this, and here we have our user friendly PBR material. See how good it looks. But for me, my favorite method is the first one. This is because we have that adaptive subdivision option in that, because it aligns the vertices wherever it is most needed, which means almost where the displacement is going on. So it requires less vertices compared to this one and provides finer details. Occlusion. Now for the next part, I will show you how to use our fifth map, which is Ambient Map. Now before starting, I will show you what is ambient. I have some images which will help you understand. So here you see this image. In real life, between the point of contact between the two surfaces, there is some dark shadow, there is some dark cast which is caused. If you use EV renderer, you may not see it, but if you use cycles, you can see a little bit, but still it's not enough. So for that we use this ambient occlusion map. Let me show you this another example. So this one is ambient occlusion. Look how clean it is looking in spite of being so dirty. But if you see this image, you see this dark edge between both the surface. That's what ambient does. Alright, so let's bring it in this. Let me straighten the lighting so you can easily see. Wait a minute. Now to use this map, I will add a mix RGB node and add this ambient occlusion texture here. Connect the color here and set this to multiply. Now what the data it offers is this black and white image. You see, these are the darker parts which I was telling you about. If you see this using just a simple plain white material, you may know the difference. Now if I remove this brick texture, see what it is doing. It's just simple plain. There is no that black edge between both of the surface, like you can see here. That's what this offers. You can manipulate it using color ramp, make it darker or lighter according to you. Plug this color here and this color here. Okay, so see this. As you can see, this is the darker part which I was talking about, that we see in our real life. You can also see them between the cracks in this cracked brick. You can sharpen it, or you can darken it further, but I see this is the best one. So to use this, plug this color into color here in the multiply node. Now you see this is the result. See how dark it gets. Now I will plug this color into base color and see our final result. Okay, so as I change slide, if I change the slider, you see those dark parts. Occlusion. The change is very small, almost negligible. But if you are working in a scene which needs to be very detailed and realistic, you can use Ambient Occlusion. Now here we have a very useful add-on. Now to enable that, you go to Edit, Preferences, and search the node Wrangler and just simply turn it on. If you see the hotkey list, you get so many useful hotkeys which are very easy and handy to use. Now what this does is it automatically assigns all the maps which you get in our PBR material. Select the principal BSDF and just simply press Ctrl Shift T. It will open a window. Now select PBR material you want. Select all of them, and if you click on Principal Texture Setup, it will automatically set up all the maps according to their data, except for the Ambient Occlusion one. So this can speed up your workflow. Now if you want to see what an individual map is offering, you just simply press Ctrl Shift and left click on it. It will show you what data is passing through that node. For example, if I click on the roughness, it will show this. If I click on the displacement, it will show the data it is giving. So it's quite useful add-on. So this is just another example. these are the PBR textures I have used. Like for example, for this rocky ground I have used this one, this wall maps, and its displacement of course. So you can play with these values and these maps and create something very beautiful using it. You don't have to model everything. Now if I change the lighting, you see how good it works. Let me show you in the denoised viewport. You get amazing details with this. As you can see how good it is. You can see how less vertices I have put it in, but still the level of details you get is so good because I have adaptive subdivision turned on. Now if you have seamless textures, what you can do is just duplicate it and there will be no seam between both. So that's it for this video. Comment down your questions and queries. I would like to answer them. And if you want a detailed video about displacement, then comment down below. Make sure you hit that like and subscribe button. If you find this video helpful, don't forget to share it with your friends. Thanks for watching.